Oh no, I have um I'll open this in a new tab. Hi, good morning, friends. Let me make sure that we are actually broadcasting and people can see us. Welcome to this thing, Rasa Reading Club. Uh, how are you doing, Vincent?
I'm doing good. Like as always, we are sort of engaged in this "is everything set up the right way" moment, which is always a little bit, a little bit tricky. But I'm good. But, I'm excited to continue on with the paper. I think it's a good one.
Yeah, I think it will be. And it looks like we are good to go and definitely saying things to the internet. Fantastic.
Okay,
Uh,
it's always nice to know the internet's
oh,
listening.
right. Sorry, I just muted. Sorry, I muted the device that I'm listening to on out of habit. And I couldn't hear you anymore.
Okay, no, like it's always nice to know that the internet is
Put
listening.
this
That's the
over.
main point I wanted to make. Um, the only thing that
Sorry, I just need
okay,
another window.
sure. Like we,
What
we
was that you
are
said?
we are live and stuff. Like do we have to check, double check, or are we already in the clear?
Oh, we should be good.
Ah,
Yeah,
okay.
yeah. Professionals. uh, let's quickly recap what we talked about last week. So you may notice, y'all who are watching, that we do not have our friend Mady here with us. She is working on something else. She might pop in a little bit later to say hi. We shall see. But last week we worked on reading this paper, Lipstick on a Big, Debiasing Methods Cover Up Systematic Gender Biases in Word Embeddings, but do not remove them, by, I think that's Hila, Gonen, and Yoav, Goldberg. And just like a super quick recap of the story so far, a lot of the debiasing methods take, you know, the word vectors for two words, such as he and she, and transform the vector space such that words where there is a well, there's no morphological component because this is English, but words where there is a grammatical role of gender. So like queen has gender information in it, monarch does not, king does. So making sure that words that do include gender information, like king and queen, are still, related to the gender vectors, and words that are not related to gender have that relationship removed. So, such as like doctor and nurse, those are both gender neutral words. There's no information about the gender of the person who has the title doctor in the word doctor. Like me, I'm a doctor, not that kind of doctor. And that is the way that people have been doing it. And what this paper shows is that even though you're sort of like collapsing for some group of words on that subdivision, you still have in the sort of relationships between these groups of words in the vector embedding space, you know, relationships that reflect negative stereotypes, sexism. They're mostly talking about sexism here, but of course any other
Ism.
categorical.
Yeah.
Yeah, any other ism would be equally well, maybe not equally, because it'll depend on the corpus. But
Yeah, but the
we're only talking
main,
about
like, I suppose the main theme here is like, hey, we have this debiasing technique, and there's two risks. Like, one, it might not be debiasing enough, and also because you might be convincing yourself that you're debiasing, even though you've still got a long way to go. And that's sort of the theme of the paper, at least for so far as I've been able to read it.
yeah, I think that's a good summary. And as I remember, we wrapped up with section 3.3. Does that sound right?
I remember there was I remember that chart.
Mm-hmm.
So the main, this was one of those charts where they said I think the purple points were like the biased ones, or the other way around. And you've got let's zoom in just a little bit, because
And I
also
think
for extra context, I've been trying to recreate these charts, so I've been busy with this. But I believe the purple dots were the biased words, or the other way around. But the main point is that before the biasing and after the biasing, if you take a look at the t-SNE dimensionality reduction, that is to say, this is just the summary, then you notice that the purple dots and the blue dots, they're not really overlapping. They're still sort of separated out. And if you And you would assume that if you debias, that then the biased words and the biased words and the debiased words will be like really easy to separate. It's sort of really hard to separate after debiasing, and that's not what's happening.
Definitely. And I think this is, I don't know which group is which, but these little X's that are purple, just for folks that are maybe colorblind and can't see the color difference. The little purple X's are one group of gendered words. The little teal dots are the other group of gendered words. Here they're very distinct. Here they're less distinct, but still overlapping. And same idea here. And I believe that the colors were assigned by k-means clustering. Does that sound right? That sounds right.
Or a word list. They also mentioned word lists up front, that they said, well, we've got these words that we know that are heavily gendered, but then we have to double check that. But the main point with these charts is, hey, we don't think that you've actually done the debiasing, because if I look at the neighbors of all the points, like if I look at the neighbor, for example, a profession that's usually done by women, then there's still a lot of professions that are just usually done by women. It's like that part seems to not be filtered out.
No. And this would be a problem for applications where you say are recruiting for a specific job role and you cannot use gender information. You want to make sure that that's peeled out. All right. Yeah, let's just read through these experimental results again really quickly, because I think that'll help us give us a little bit more.
Refresh the memory a bit. Shall I take the first paragraph?
Yes, please.
So number 4, experiments and results. Male and female biased words cluster together. We take the most biased words in the vocabulary according to the original bias. 500 male biased and 500 female biased. So I think that these were word lists that they started with that they already had, and cluster them into 2 clusters using k-means. Okay, so they do the clustering, but I believe that that's to give the label to the cluster as well. For the hard debiased embedding, because they were checking this on 2 debiasing techniques. For one of them, the cluster aligned with an accuracy of 92.5 according to the original bias of each word, compared to an accuracy of 99.9 with the original version. And the idea is that the difference between 99.9 and 92.5 is not super duper big. I think that's the main point they're trying to say. Yes, you're filtering out something, but it's not, like, the bulk of it is still there.
So the sort of like goal here would be, because it's 2 classes, 50% would be like no bias. It's just be random guessing. Yes.
So definitely, you're walking in the right direction, which is fair, but it's... Now, I am curious on how they got to 99.9% though, but I don't know. Rounding error, I guess.
I think these were also the most biased terms that were provided by the people who developed this method.
Could be. Yeah, that might be it.
Oh, you mean why is it not 100? I was like, I thought you were asking why it was so high.
No. Like, why is it not 100? That might be. No, either way. We'll call it the rounding error for now. It's the main point.
It's stochastic.
Yeah, like it's for most intents and purposes, we can just say it's 100. Anyway, that's for one debiasing technique, and then for the other technique, they get an accuracy of 85, which is definitely better compared to an accuracy of 100% with biased. But I would argue that 85 is still nowhere near 50. So they say here in both cases, hey, we have this other test, and the biasing doesn't really score well on that test. And to read the sentence out loud, these results suggest that indeed much of the bias information is still embedded in the representation after debiasing. And then they mention, so that's where the color indeed comes from. I believe the color is then the t-SNE of the k-means. And the main thing that you see is that the clusters in essence just persist, and you would hope that there's more overlap, but there's barely any extra.
Yeah. And as I remember, the GN, I think that stands for gender neutral glove, their debiasing method, instead of sort of like folding the vector space, if you will, was to create the last dimension was only gender information, and then they removed the last dimension from the, I would say 300, 500 dimensional embedding.
I think it's 300. Quick question about, can you hear the seagulls over the mic?
I can, it's nice.
Okay, I can also close the window.
Atmospheric.
Okay.
That's fine.
I can close
I know it's pretty hot where you are, so.
It is. But yeah, but I think there was one debiasing technique that's sort of this post-processing thing where you remove a vector, and there was this other technique that did something during training, right? Something where they try to force the gender information into like one index of this embedding, and then they filter it out in hindsight, something like that.
Yeah, I think the GN glove was the one that was done during training where they remove the vector, and then it's like peeling it off like wallpaper. I don't know why that's my visualization. And then the hard debiased is done post-processing.
Yeah, and that I remember from the previous week, because we did notice that there's also a disparity between both of these debiasing methods, and I would argue it also makes sense that if you try to fix this during training as opposed to in hindsight, you should also get a slightly better result. And indeed, that does seem to be the case.
Sorry, this is speaking of atmospheric sounds. I've got some chair squeaking. I don't know that I would have had a strong intuition a priori, whether it would be better to identify this during training or try to do it post-hoc. Sorry, that was a lot of Latin.
No,
I don't know. Just like with no other information, if I would have thought that it was more effective to identify gender bias during training of the embeddings, or to wait until the embeddings were already trained and then try to move the final model.
So the reason why it sort of makes sense to me is more that usually the earlier you introduce a constraint to any system, like the better. Like if you make sure that like the earlier in the pipeline you try to address something, I can imagine at least, I'm sure there's like counterexamples, but I would argue it's somewhat intuitive that you can accomplish more by just trying to address the problem as early as possible. It's more on that axis of thought, I'd say.
Oh, one sec. We've got a connection issue.
Oh dear.
One sec, let me know the chat. Connection is flaky, reconnecting now. Alright, so it'll just reconnect until it works.
Okay.
What I was thinking about, we're live again, is, so word embeddings and word vectors they draw on this idea of distributional semantics, where meaning is encoded with the way that things are used together. And if you have a language where like there's a morpheme for gender and you can like use a rule-based system to identify that, I think that that's going to be, I would definitely agree earlier in the pipeline would be better for that and deciding how you want your system to handle it. But if you are just using this co-occurrence measure as a proxy of meaning, the reason why I think that post-hoc make more sense, or like after the fact might make more sense, is because you don't necessarily know what's in your training corpus and what the specific biases are going to be. Like the list of words that they bring up, these ones. So these are words that are most male or female biased. So like petite, mums, bra, breastfeeding, sassy for female, and rookie, burly, hero, training camp, and journeyman for male. I wouldn't necessarily have picked those words out to begin with as going to be the most biased words. You know what I mean?
Yeah, there's right, you get this other way. Ironically, you get this other bias, namely, what do you think is actually gendered? Because you're only going to be correcting on that.
Yeah. And it's also definitely going to change, like, over time. And so, for example, a word that is highly gendered, but probably not going to be in most of your training corpuses. Are you familiar with the word simp? S-I-M-P?
No.
It's like an insult for men who treat women with respect, as far as I can tell. I would say this is not a word that I use, but I've seen it used. So it's extremely gendered, and it would probably come out of a corpus as something that's very associated with one gender rather than the other, or one gender as opposed to a different gender.
But a lot of curse words have that property, I think.
I don't think it's a curse word. I think it's just like an insult.
Well, sure, but like, a lot of insults, curse words, they often tend to have like a gendered thing attached to them. Like take the word bastard. Like that's typically, you typically yell that to a guy, in my experience, watching movies, right? Okay, so that's but it's fair to actually point this out because this is also kind of the hard part of bias as well. There's a lot of opinion in this sort of thing as well.
Definitely. And there might be, we are not reading much of the paper, but I think this is a good discussion to have. There might be instances where you don't want to remove the bias, right? So you're talking about insults. If you're working on something with abusive language, you might want to keep this vector in and be like, oh, hey, these words that are extremely gendered are maybe more likely to be insults.
Yeah, I remember the, I forget which one, but I believe one of the first insult detectors sort of had this issue where, like the word gay, for example, can describe someone's sexuality, but it can also be a slur. And you get into all sorts of hairy territories there. Language is a hard language is a hard problem.
Language is a hard problem.
Yes.
Jigsaw. So, like, very neutral statements like, I am a gay black woman. I am obviously not black.
Yeah.
But, like, statements like that would receive a very high toxicity rating. Whereas statements like, I'm a straight white man would receive a very low toxicity rating, even though, like, those words in that order, if you were describing yourself, are neutral. Enrique says, does just removing the he, she words help to debias? So the big problem with that is those tokens will still show up in your data when you apply your model, and now they're out of vocabulary.
I mean,
Out of vocabulary.
If it's out of vocabulary, you can still, well, here's a vector of zeros instead. I mean, there's numerical tricks that you could do, but I would agree that throwing away data often isn't the solution either, because you do want to maintain some of the information. And in the case of he, she, I would actually argue there's a lot of information in those words, namely someone's gender, and that could be relevant to the text that you're currently analyzing. Just like king, queen, I can argue there to some extent that the meaning of the word, indeed, like king, for example, the gender is actually part of the meaning of the word. It'd be king and queen cannot be the same thing. You have the word monarch, but the main problem that I would have here is, I guess, the word nurse. That should be independent of whatever gender you have. There's no reason why men couldn't be a nurse or why women couldn't be a nurse. However, these are patterns that models might pick up, and that's where sort of the danger starts.
Yep, very much so.
All
right, let's keep reading the paper.
Yes.
But I think this was very, I don't know, hopefully it was helpful for folks. I have been enjoying the discussion.
Yeah.
Bias by projection correlates to bias by neighbors. This clustering of gendered words indicates that while we cannot directly observe the bias, i.e. the word nurse, from your example, will no longer be closer to explicitly marked feminine words, the bias is still manifested by the word being close to socially marked feminine words. For example, nurse being close to receptionist, caregiver, and teacher. This suggests a new mechanism for measuring bias. The percentage of male-female socially biased words among the k nearest neighbors of the target word. Footnote. While the social bias associated with the word cannot be observed directly in the new embeddings, we can approximate it using the gender direction in non-debiased embeddings. So, what they're saying is that even if you have moved things in the vector space, if things have the same relationship, let's say I work for a job board and somebody, uploads their CV and they say, oh, I've been a nurse in the past, and I'm just using vector space semantics to recommend other jobs to them. Or even if they don't say they're a nurse, but they include like he and she pronouns in their resume, or one or the other, if I'm more likely to use that vector space embedding and be like, oh, you should be a receptionist, you should be a caregiver, you should be a teacher, or conversely, like you should be an executive, and you're only showing job ads for people who, fall into one or another of these categories. That's a problem.
One thing I suppose is maybe also fair to mention is we're definitely zooming in on the recruitment pipeline problem here, right? And one thing that might be fair to mention is it's like one area where there might be issues. Potentially, there's definitely many. If I think about recommenders, for example, like filter bubbles and that sort of thing can also be related to some of this stuff here. So we will be zooming in on the recruitment mainly because I think that's the easiest example, but we wouldn't want to suggest the only area where there are problems.
No, definitely not. I like to use it as an example because, at least in the US, it's one with legal ramifications.
Oh,
I'm assuming also in the EU.
I cannot speak for the entire EU, but I'm assuming so. At least in the Netherlands, it's definitely no-no territory.
Let's finish up this section.
Yep.
We measure the correlation of this new bias measure with the original bias measure. For the hard debiased embedding, we get a Pearson correlation of 0.686 compared to a correlation of 0.741 when checking neighbors according to the biased version. For GN glove embedding, we get a Pearson correlation of 0.736, compared to 0.773. All these correlations are statistically significant with p-values of 0. That's not a thing that a p-value can be.
I'm just peeking below, and then I see a p-value that's less than 1 to the power of minus 30. I'm assuming 0 is approximate. I do agree it should not be theoretically 0. That's not how that works.
No, it is not.
So it's a rounding error, I hope.
Yes. But Pearson's correlation, so this is a correlation measure where 1 is perfect positive correlation and -1 is perfect negative correlation, 0 is no correlation. So 0.6 and 0.7 are pretty high.
Yeah. If it would be higher, it'd start getting suspicious. Like, those are high correlation numbers. Yeah. So this is interesting. So can I continue?
Yes, please.
So professions. We considered a list of professions used in Bulkowski and Tsao et al. I hope I pronounced that correctly. In light of the neighbor's bias definition. In figure 2 plots the profession, with the x-axis being the original bias, and the y-axis being the number of male neighbors before and after debiasing. Okay. So there's a clear correlation. Can we scroll up then?
Yes. I'll zoom in a tiny bit and see if I can center this. I cannot. I'm just going to zoom in on one of them first, just so folks can see the labels, because they are pretty small.
Yeah, and I think the story is relatively similar, but so one thing that we see some words. On the left-hand side, we see words like nurse, librarian, nanny, receptionist, hairdresser. I'll assume those are the stereotypical female words.
I assume so, yeah.
And on the right-hand side, you see warrior, skipper, captain, coach, and commander.
I think so.
I think, and then in the middle, you see banker, archaeologist, warden, consultant. They're not really perfectly in the middle. They're still a little bit more to the male side, and also so far that makes sense, I think. And what they're trying to get to is in the original and the bias, there's definitely a positive correlation. You do notice that it's like the original correlation, I guess, if you look at the left-hand side, like it's more of a upgoing line in the original, and it's a little bit more flat in the debiased, I guess.
Right, but overall, I'd say the relationship is very close.
So
it looks like it's gone slightly fatter and flatter.
But I wouldn't argue there's no change. That's the main thing. Like, I see some of the change, but to look at the chart and say, oh yeah, there's no correlation now, that's not true.
Yeah, I could draw a line through here pretty easy.
Yeah. And
so this is the hard debias. This is the post-hoc one, and this is the one where there is a vector for gender.
Oh, that one's worse even. This one really didn't change much. It changed a little. It changed a little, but I wouldn't argue it changed a whole lot. And every point here was a profession, if I recall correctly, right?
I believe so, yeah.
Yes.
And it looks like there's actually slightly different professions here. So we have colonel, coach, warden, commander, farmer, and mentor. And as I remember, warden was sort of in the middle here. Yeah. So that's in the glove embeddings, that's a more profession. And here it's in the hard device embeddings, it's sort of more of a neutral profession, which may be down to the training corpus.
Yeah, but the point they're trying to make is that given that it's in the original on the far right-hand side, in the debias section, it's still there.
Yeah.
So I think that's the main point, that the technique simply doesn't work on their own data set.
Mm-hmm. Well, I mean, it works by the measure that they use, and I think the paper's pointing out that they're like, hey, there's other measures, and by those measures, you haven't solved the problem.
Yeah, no, that's fair. That's fair.
In the middle here is archaeologist, magician, dentist.
Skipper, comic?
Yeah.
Musician, magician, and dentist.
Mm-hmm.
Okay.
And the down here, nurse, dancer, which I think wasn't in the other one, receptionist, housekeeper, and nanny. So they're using slightly different set points.
Still, I will say, to me at least, it does. Yeah, I don't know. It might be life experience as well, but I will say that to me it feels like the female professions here are a little bit more on the stereotypical side than what I see on the male side, if I'm honest. Like farmer, that could be either gender in my experience in real life, but it's hard to say. This depends on real life experience. That can be different, but either way, the main point remains clear. Yeah, the correlation persists.
Definitely. Enrique says kind of unskewness. So it's skewing the data slightly less to do the debiasing. But there's definitely still,
Yeah. Okay.
Bias involved.
And just to check once for one last time, the x-axis that we saw was the original bias, so that's the I suppose?
Yes.
And then y being the number of male neighbors in the top n. If they do like a k nearest thing, like the nearest 100 professions from that point, how many of them are male?
Yeah.
Right.
So, as I remember, 0 is by both of these measures sort of like the unbiased, and then more positive is more male, and more negative is more female. And it's a range positive to -1.
Yes. But the main thing that you see here is, sure, what we've done is you might have that male-female axis might be different, but if you, I guess that's the main point.
Yeah, sort of going.
Nurses are still very similar to nannies, even though potentially the latent state says, well, it's nanny might be closer to warrior, but if librarian and nurse are still closer to nanny, then you can wonder, well, how much has really changed?
Definitely. Sorry, we're having stability issues again. So I'm just letting the chat know that we're reconnecting again.
Okie doke.
Also, I did look into changing ISPs, and none of the other ones that are available in my area are any better. So
ISP stands for Internet Service Provider?
Provider? Yep.
Okay.
So, which is, I don't know how it is where you are, but in the US they are private companies.
So I think here there are also definitely private companies. It's just that the network is run on a sort of government level in a way. But either way, it's still complicated.
Yes.
I think I can read on the next paragraph then.
Oh, please.
Are we connected? Okay. We observe a Pearson correlation of 0.600, 0.606 compared to a correlation of 0.747. Lower, but still definitely a positive correlation. When checking neighbors according to the bias version for hard debiasing, and 0.792 compared to 0.82 for the other GN glove technique. All these correlations are significant with p-values not 0, but less than 10 to the power of -30, which I will argue is small.
Yes, it is small. Quick word about reporting p-values. So what you do first is you pick an alpha. So you're like, this is the p-value that if my p-value falls below it, I'm going to take it as evidence that I can reject the null. And all you report is whether or not your p-value is above or below that alpha, and that's all you do. You do not report
what the value
that it's
is.
very small.
Yeah. I mean, in this particular case, I don't know if I'm assuming they're not joking, but in this case, like looking at the charts, I don't know if I really need a p-value. I think the chart kind of speaks for itself. I think it's formal. It's probably nice to add, but for me at least, I wouldn't require it. Just looking at the chart, I would argue, hey, this something's amuck here.
Yeah, definitely. Enrique says housekeeper is still female. Yeah. Even with the debiasing, there's still, problems.
Yeah.
Well, not necessarily problems, but still like underlying patterns that you may not wish to amplify. And Benjamin asks, are debiasing methods used in Rasa NLU? You want to speak on that, Vincent?
Not from the get-go, but it depends. So the thing is, at the moment, if you just run Rasa init, this might change in 2.0, but I think right now we only use the count vectorizer and the lexical syntax feature. So the standard pipeline that you currently, like, if you just do Rasa init, the standard pipeline is not using any word embeddings. However, what you can do is you can add spacing and use those embeddings. And what you can do is you can use convert and BERT, and I'm working on open source projects such that we can also have fast text, and you can add them yourself, but those that you add typically, as far as I've seen, are not debiased from the get-go. So what I would like to maybe add there is that it's not like we're not concerned about it, but we have this constraint built in the sense that usually these embeddings are going to be used for intent classification and entity detection, and those use cases, typically you can add a logical constraint yourself, as long as you're not, odds that you're going to be using this to parse resumes are fairly small, also because we're dealing with very short sentences. So part of this responsibility we do give to the person who's designing the digital assistant. But I think as far as the application goes, the risks of technology like this are much higher for resume parsing than when you're building a chatbot to buy a pizza. And that's sort of sort of how I look at it. The risks for Rasa are a lot smaller. So we are definitely concerned about it, and when we try to make tools to make this sort of easier to analyze. But definitely, if you're using any word embedding, you have this problem.
Yeah.
So also in Rasa.
Definitely. And I would say so definitely for some applications, they're more of a problem, and also for some approaches. So if you are doing something completely end-to-end, or you are doing text generation, then I would say this would become much more important for you to worry about.
Yeah, so I think the nice thing about having intents, I mean, it's like if we're going to dream...
It's a little waypoint in the middle. You can check in and be like, how's it going?
Yeah, it's a constraint, right? And that's kind of the nice thing. But you still need to iterate on your data and all of that stuff. But we should be honest here. Like, any word embedding that I've played with, and I'd like to think I've played with a few making some open source packages, every downloadable embedding that I've tried this on fails this test. Like, they're all biased in some way, and that makes sense because language is biased. So that's just something you're gonna have to keep in your mind when you're designing anything using word embeddings.
Definitely, it's a constraint of the technique.
I think
Yulong.
Yep.
Okay.
Well, so there's one extra comment. So internally, I hang out with the research team from time to time. So one idea that we had a while ago was like, okay, if Wikipedia is maybe a little bit biased, can we sort of so it's fairly biased, but can we come up with maybe a different data set where we can sort of have guarantees that the data is less biased? But very quickly, like, even if you take the dictionary, which I would argue is maintained by a couple of, I don't know, maybe not scholars, but people think carefully.
Scholars.
Some of them are scholars, but
lexicographers, yeah.
Yeah. So, but even there, you still have to deal with history. Historically, certain jobs were more available to men than for women, and even in a dictionary, that's going to persist, even the ones you trust. So it's just a hard problem. It's fairly unlikely you're going to find a word embedding where bias is not an issue.
Yulong's question is... Oh, two questions. In the training data, the frequency of nurse and she show together in sentences are higher or maybe lower than nurse and he. And considering the mask language modeling task, BERT might capture more information of she than he. Oh, sorry, I missed the first one. Does such bias in vector space show up because of the combination of models training task and the word distribution in the training data? Yeah, it's 100% from the distribution of words in the training data.
I can imagine one thing I suppose is fair is I can imagine that maybe certain approaches are able to exploit it more, right?
Yeah.
But the source is probably still the data, and models are probably just amplifying it. That's the short story. I can't imagine.
That's a great summary.
I can't imagine though that certain models are worse, but the main thing I would do is don't be naive. No matter what approach, your word embeddings are probably going to be biased.
Yeah, and I think we're talking about embeddings here. Definitely applies to any sort of language modeling thing as well, because again, that's words that are more likely to be used together, more likely to be generated or be closer together in vector space. So.
Or any data, house prices, or like tabular data. You also have this issue, I think. But yeah, we're focusing on text for today.
We are. And speaking of text, let's jump back in.
It's a good segue.
So, thank you. Association between female, male, and male stereotyped words. We replicate the 3 gender-related association experiments from Kaliskin et al. I might be saying that wrong. For these experiments, we use the full vocabulary since some of the words are not included in the reduced one. Scroll up. The first experiment evaluates the association between female-male names and family and career words. The second one evaluates the association between female-male concepts and arts and mathematic words. Since the inherently gendered words, e.g. girl, her, brother, in the second experiment are handled well by the debiasing models, we opt to use female and male names instead. The third one evaluates the association between female-male concepts and arts and science words. Again, we use female and male names instead. Little footnote. All word lists taken from Kaliskin et al. 2017. First experiment, female names: Amy, Joan, Lisa, Sarah, Diana, Kate, and Donna. Wow, that's very European. This is a very small slice of female names.
Male. I think they only do a subset, though, right? Is this only a subset, or is this the entire name list?
I think this is the whole name list.
Really? Oh. Huh.
Male names: John, Paul, Mike, Kevin, Steve, Greg, Jeff, and Bill. Family words: home, parents, children, family, cousins, marriage, wedding, relatives. Career words: executive, management, professional, corporation, salary, office, business, career. Second experiment: art words: poetry, art, dance, literature, novel, symphony, drama, sculpture. Math words: math, algebra, geometry, calculus, equations, computation, numbers, addition. Third experiment: art words, poetry, art, Shakespeare, dance, literature, novel, symphony, drama, science words, science, technology, physics, chemistry, Einstein, NASA, experiment, astronomy. That's the word list.
One thing I think it's worth to point out here, like, I don't want to suggest that coming up with really good word lists is inherently an easy thing. I think it's definitely hard, and yeah, I mean, I'm interested in contributing there because I think it's really important to have like proper word lists. That said, we understand then, I suppose, that we only have 10 names, like collections of 10 words. That's what we're dealing with.
Yeah.
Okay.
And very, very, for the names, very limited in their sort of cultural scope.
To me, they all sound American, to be honest. But it's made like Donna, like even in the UK, I don't know, like
it's old.
So I suppose so. Well, okay, let's say US and UK names. I think that's fair, at least fair. I definitely think that Donna is like, if you go to Germany or France, you're never going to hear.
That's true.
That's someone named Donna. But...
WASPy. I would say these are pretty WASPy names. WASP stands for White Anglo-Saxon Protestant, which is sort of like a slice of demographic in America.
I suppose that's accurate. That sounds fair enough.
And I will finish this section, and then you can take the next one.
Sure.
For the hard debiased embeddings, we get a p-value of 0 for the first experiment. I appreciate that they are using inferential statistics, but this is maybe not the most...
Not the best way to do it.
Yeah.
But the main thing they're saying... Okay, so... yeah, let's just read it, I suppose. But...
What they're saying is there's a very strong relationship. So very small p-values. For the Jan Glove embeddings, we get very small p-values for the first, second, and third experiments, respectively.
I would say the third one is not necessarily super small.
This one? Yeah, it would depend on what your alpha was.
Yeah, exactly.
So usually in social sciences, it's pretty common to use 0.5. Sorry, 0.05. Not 0.5.
Yeah, that's optimistic. Okay, no, so that's true, but I think, I will say, like, hey, 0. Okay, that's not the lowest, I would say. Definitely not 0, but then again, neither is 0.
And also, anyway, if you're interested in learning more about inferential statistics, I recommend the Open Stats textbook. I'll pull it up really quick. which is free online and has been written by statistics professors. There we go. So it is openintro.org/book/stat. And all the PDFs are free, and you can get the paperbacks for $28 if you would like them.
Oh, never heard of Open Intro. Sounds like a cool website.
Oh, it's fantastic.
It's
an open source textbook.
Oh Lord, I was looking for this. Yeah, okay. So, I have beef with educational textbooks, so this is amazing. Nice.
You mean the racket?
Anyway, it works a bit differently in the Netherlands, but still, I think that at some point you shouldn't have to pay like $80 for knowledge that's been around for 200 years.
But how will the publishers make their big piles of money that they roll around in, like Scrooge McDuck? Vincent?
I have yet to see someone roll around in money and not have it look like a like a train wreck. But anyway, that's the segue back to p-values. Classifying previously female and male biased words. Oh, sorry, that's the topic. Classifying previously female and male biased words. Can a classifier learn to generalize from some gendered words to others based on only their... Oh, this is going to be fun.
There we go.
Only on the representation. We consider the 5,000 most biased words according to the original bias, like 2,500 for each gender. And then they're training a support vector machine with a radial basis function kernel, machine learning model. They train something scikit-learn on a random sample of 1,000 of them, 500 from each gender, and then they're going to check if it generalizes. I think that's kind of a nice trick, because it's not necessarily the most high-tech classifier that they're using. It's relatively off the shelf, but you could say, hey, if based on just like 1/5 of the data, we can predict the next 5,000, and you would argue, well, something's general is still in there. That's fair. For the hard debiased embedding, we get an accuracy of, oh dear, 88%, compared to an accuracy of 98% with a non-debiased version. So you can definitely say, okay, 10% accuracy is lost there. Man, but still, like, this is really important, because this I think is the strongest point. Imagine you're in a team and you're telling yourself, hey, I've been doing this debiasing thing. We're in the clear. Like, you're so not.
1 second, I'm gonna paste the link in chat because somebody asked for us.
Go ahead. No, because this is, I think, also with some grid search things, something that's actually kind of dangerous. You can convince yourself that you're doing the right thing because you're optimizing towards this one single statistic, right? And here you kind of have this nice proof of, you've only filtered out maybe 10% of the danger. Just not enough. And it's even worse for the other one, I think. For the GN glove embedding, we get an accuracy of 96 compared to 98. So it's, okay, that's interesting. Like, I think I don't know what to think about this particularly thing, because I think if you're a company and you're saying, hey, we're going to apply these debiased techniques, because then in hindsight we can always say it's been top of mind and we do think it's important, then there's something noble about that, which I would like to acknowledge. But at the same time, just looking at this simple experiment, you do kind of go, right, but it's so far away from what's sufficient, you really have to be careful with that.
So I was just scrolling back up to look at the Pearson correlation, and then coming back down to look at the gender biased words. And I am noticing that in general, the hard debiased embeddings saw more improvement than the GN glove. And I think this relates to Yulong Chen. Can we remove or detect such bias by applying different way of training task? So to answer that question, the GN glove embeddings did include gender as like a task in the training task, basically. And one of the vectors, or one of the sort of dimensions of each of the vectors, is the gender dimension. And what they did was they removed that, and that's how they debiased the embedding. And then the hard debias, they take the entire embedding space and then transform it such that words like monarch and royal that don't have a gender bias should be that don't have gender information in the word should be, between he and she in the vector space, and words like king and queen that do have gender information in the word should be closer to he and she. So that's basically what they did. And based on these results, it seems like training the vectors and then modifying the vector space seems to have more of an effect on moving apart words that are sort of like stereotypically together than using gender as part of your training task and then trying to remove that information after the fact, which is interesting because as I remember in the original paper, the GN glove embeddings were more effective at the specific task that they were working on than the original. So the hard debias method came first, and then the GN glove was the extension of that.
I guess you could almost. Well, I don't want to suggest this, I suppose, but you could perhaps argue here that the results might have been better, but it might have also been overfitting in that sense.
Yeah, very possible.
And also, like, there might be a debiasing trick out there that solves everything, but it's just that we probably aren't aware of it.
I find that unlikely.
I also find it unlikely, but I think it's fair to mention that, still investigating these approaches is still a noble task, right? So if people say, hey, there still seem to be problems with these approaches, can we maybe improve them? I think that's fine. That's actually great. But yeah, like, this is I would argue this is like RBF, SVM, it's like not really state of the art. It's not like they really did a lot of effort there.
Hey, I like SVMs.
Oh, they're great, right? But let me put it this way. But it's not like, looking at this, it's probably that they just imported scikit-learn and sort of had to go with it, and that they spend, if I read this, when that they really spend a lot of time tuning the hyperparameters to get these numbers as high as possible. Like
they weren't juicing this to get like the best, classifier.
Yeah. Like, definitely, like, if they used a logistic regression here, I would have gone, you can do better than that. But like, this is fine. This is fair.
And I think also SVM makes a lot of sense as a model for this particular application because word vectors are in a vector space, and SVM works in a vector space where things that are farther apart are considered least like each other. So.
Yeah, and it's also non-linear. I think that's also fair to mention. It definitely feels like this is a non-linear space, so a logistic regression would have been a, kind of a cheeky choice here.
No.
I find one thing I do want to make. I find this the strongest argument. Like, this is the easiest to explain, I think, as well. So this is a nice final addition.
And just checking in with the chat, Enrique says, Donna from the song. Like, Donna Summers? I don't know what song you're talking about.
I think I've never met a Donna. Like, I recognize the name, but I've never...
And then Enrique says, p-value 0 is like saying the probability is equal to 1, isn't it? Oh, wow. Gosh, the minute since I dusted this off. They are way less intuitive than you would like them to be. So...
In general, by and large, the main thing I'm trying to say here is it's most likely not due to coincidence that we see this number.
Yes, that's the argument that they're making.
Yeah, and like, anything closer to like the actual formal definition, I'm not comfortable making without checking my textbook. That's if it's Bayesian statistics, I know I can dream that, but like the whole Frequentis thing, you have to be careful because it's quite formal and it's easy to make like a very subtle mistake that makes a lot of impact.
Yeah, it is. I will say p-values are not probability. Is the easiest way to, I think.
Which it would be nice if
everybody.
Well, it'd be nice if like p-values took a different letter, like not the letter that also starts the letter probability, because it's implied. Anyway, you want to take this one?
Sure. I was just trying to remember who I read last. Discussion and conclusion. The experiments described in the previous section reveal a systemic bias found in the embeddings, which is independent of the gender direction. We observe that semantically related words still maintain gender bias both in their similarities and in their representation. Concretely, we find that 1. Words with strong previous gender bias with the same direction are easier to cluster together. Words that receive implicit gender from social stereotypes, e.g. receptionist, hairdresser, captain, still tend to group with other implicit gender words of the same gender, similar as for non-debiased word embeddings. The implicit gender of words with prevalent previous bias is easy to predict based on their vectors alone. Yeah, so just to summarize this, generally, yes, doing debiasing helps a little bit, but these relationships are the same. The relationships between highly gendered words that you want to remove gender information from does not change. Enrique says Richie Valens. I'm just going to look up the song real quick. What was that, Vincent?
Oh, so one thing I do want to just say is all three of these arguments are pretty strong as well. Like sometimes a paper only tries to sort of focus in on one argument, and this paper provides three, all three of which I would argue are valid. To me, especially the last one is especially strong. Also because I like it's going to be relatively easy to try and replicate that, and I can definitely see how that confusion matrix is not going to imply that bias is gone.
Yeah. And I looked it up, and the song is called Oh Donna, and it's by Richie Valens. I don't think I'm familiar with it, but if you would like to listen to it on your own time. Do you want to take the next section?
Yes,
because a little bit more.
Yeah, and I agree with the next four words. The implications are alarming. While suggested debiasing methods work well at removing the gender direction, the debiasing is mostly superficial. The bias stemming from the world stereotypes and learned from the corpus is ingrained and much more deeply in the embedding space. We note that the real concern from bias representations is not the association of a concept with words such as he, she, boy, girl, nor being able to perform gender stereotypical word analogies. While these are nice party tricks, I like the word party tricks, algorithmic discrimination is more likely to happen by associating one implicitly gendered term with other implicitly gendered terms, or picking up on gender-specific regularities in the corpus by learning to condition on gender-biased words, and generalized to other gender-biased words. I.e., what does IE stand for, actually?
Id est, so it's like an example.
Oh, it's like Latin, or?
Yeah.
Okay, that's why. I've been reading some more papers lately, and I've been trying to come up with like the English abbreviation here, and I just couldn't come up with anything. But
wait, sorry. EG is for examples. IE is. Yeah, I'm just gonna look this up real quick.
We kind of have to know now, don't we?
Right?
Yeah.
IE stands for id est, that is, and is used in front of a word or phrase that restates what has been said previously.
So it's like a different way of saying it.
EG stands for exempli.
Okay.
Gratia? In Latin, and means for example.
Okay.
The other one that shows up a lot in linguistics papers is NB, which is like note bene, which is like take note of this in particular.
But so the funny thing is, but that one is Dutch. In Dutch, people say note bene. Yeah, no, so that's yeah. So the south of Holland has like some Latin roots in them, because that was the south of Holland actually got conquered by the Romans at some point.
Oh, interesting. I was gonna say like Dutch is definitely Germanic.
It's certainly
like that. I know for sure.
Yeah, but the thing is, like, the region where I was, this is a different topic, but the region where I'm from, that's also like semi-Belgian, semi-Flemish influence in the language. And that was actually kind of France for a while, which is definitely Latin. It's an English, so Holland has like so many dialects as well. But anyway, they sort of come up with this emphasizing example where they say a resume classifier, again, obvious example, that will learn to favor male over, I assume that I can female candidates based on stereotypical cues in existing and biased resume datasets, despite being oblivious, quote unquote, to gender. Our experiments show that such classifiers will have ample opportunities to pick up on social cues also after debiasing with regards to the gender direction. I think this is like a nice way to maybe compare this to a tabular dataset. Like if you look at house prices, I can definitely imagine that there's neighborhoods where, I don't know, people are poor. And therefore, because poor people live there, the house price is going to be lower. But I'm not allowed to know your income, but I am allowed to know where the house is. Okay, so you could then, not knowing that one removing that one term from your data set doesn't mean that you're no longer biased on it. And this is sort of the same thing, but in a linguistic sense. I guess I'll wrap the paper up as well then.
Oh, yeah, please.
The crux of the issue is that the gender direction provides a way to measure the gender association of a word, but does not determine it. I think that's a really nice sentence. The biasing methods which directly target the gender direction are for most part merely hiding the gender bias and not removing it. The popular definitions used for quantifying and removing bias are insufficient, and other aspects of bias should be taken into consideration as well.
Yeah.
This is a good paper.
Yeah, no, I think it was very solid.
Yeah.
Quick acknowledgements. The work is supported by the Israeli Science Foundation, grant number by the Israeli Ministry of Science, Technology and Space to the Israeli-French Maimonides Cooperation Program. So using the acknowledgements, you're like, here's who helps with the work, and here's the grants I got.
Yeah, that's always
and then the references.
Fair. Some references. No, I think this is a nice paper. So
I think this was an ACL paper. I don't think this is the correct citation.
That's. I hear the Rachael detector is happening again.
Okay, listen. I still review papers because I can't say no. If you're citing a paper that's been published at a conference and you cite the archive version, you need to go back and read the published version and cite the published version. Archive is a preprint server. Once the paper's been printed, that becomes the canonical citation. That's it. That's my.
No, and I suppose it's fair enough. No, so one thing
that something interesting to look at.
One thing that I think is sort of nice about this paper, like. So people might know this. I'm maintaining this package called What Lies, and one of the things that I wanted to do with that package was to figure out what lies in word embeddings. And the main reason why I figured that package would be nice was because I thought, hey, there's not a whole lot of debiasing tools out there, and I might be able to write this tool that does all of these debiasing techniques. And you can actually see, like the first thing you see that is kind of the logo is also exactly what the package can do quite easily. So you can say, hey,
I can't scroll sideways. It's too reactive.
It's make docs template. Sorry, there's no React happening there, I think. But
isn't reactive like when you like it changes the output of the website as you like zoom in and out?
Could be.
Is reactive not the term for that?
It could be. Like I'm not really a front ender. It's just I know enough to get by.
Same. I'm just gonna look it up just real quickly.
Yeah, sure.
Because that's definitely what I've been saying. Responsive.
Reactive
is not the word.
No, you're responsive.
It's too responsive.
Yeah, I see what you mean. Like, it also works on mobile. That's responsive. That thing. But anyway, as you can see from the logo, like one of the things the package makes a lot easier is just visualizing from the notebook what these word embeddings have. And one of the things that I was really proud of in the beginning is that one projection thing you see there. You see that man bar queen minus king. Like that's the direction for man. If you want to project it away from what queen king might be, and if you do that for both man and woman, they start pointing to the same embedding. So I was really proud of making this. And then when I started playing with it, I noticed that, it didn't really feel too much as if I was debiasing a whole lot. I would still get these weird results. And then Rachael mentioned this paper, and I started reading it. And now I'm of the opinion that this package serves, if anything, as a warning. So I was trying to reproduce some of the stuff in that paper. So I was trying to debias the word, like the male-female direction. And there was this, like maid was one of the terms in there that I figured I should try. And in the non-debiased version, mistress is something that still sort of is heavily associated with it. So then I figured, ooh, that's bad. I should debias. After debiasing, the distance between mistress and maid became smaller. So it's like, and the thing is, like, I think it's going to be really hard to come up with a embedding for the word mistress where there's nothing of gender associated with it. It's kind of in the meaning of the word, unfortunately. Yeah. But anyway, these are...
Which I think is also particularly historically true of maid as well.
Oh, I think that's fair to say. Yeah. But also to emphasize, it's a really hard problem. Like, and if you want to deal, like, if you still want to use word embeddings, the best way to deal with this phenomenon is just to worry more about the application than to worry about how you can remove the bias. Because I think, just from the definition of it, it's almost an impossible task.
Yeah, I think that's So I'm trying to think about like given this, what is my recommendation to developers working in NLP? And I think a couple of things that I would say. So one is the more structured prediction tasks you have, the more sort of intermediate steps you have in your model, the easier it is to notice these things happening and sort of ameliorate them. that was a bad word. It wasn't a bad word. I think that's just a low frequency word. The easier it is to sort of reduce these effects. So this is something that I've said before, like end-to-end systems are cool, but the problem is that you're really held hostage to, it's particularly to NLP, whatever's in the underlying corpus. And a lot of web text corpuses in particular, and I'm not just putting web text, the corpus, on blast, tend to draw very heavily from Wikipedia, tend to draw very heavily from Reddit, and both of those sites have a strong bias in them towards, particularly towards like talking about men. There's a really big project on Wikipedia that's been going on to try and incorporate more biographies of notable women and, also help address some of the, general imbalances in topic area as well in Wikipedia. So like the math and machine learning section of Wikipedia is fantastic. It's very, very fleshed out. Whereas like, let's say the weaving section of Wikipedia is pretty bare bones. And when you consider like the total amount of human time and attention that has been paid to these two topics, weaving has way more like weight in the history of human cognition than machine learning does. And that's not reflected in the underlying text. So be aware. That's my first point. Is it?
Yeah, no, so I like to think in constraints and sort of safety mechanisms, if that makes sense. So if and also feedback mechanisms and that sort of thing, because especially with especially in recruitment, right? You only know how well the people are at their job. Like only the people who actually get the job can you measure. So immediately there, right? It might be the case that you're turning away a whole lot of talent, but you have a blind spot because you've never tried it. So you get this sort of feedback mechanism that's also a self-fulfilling prophecy, and that's where the real danger starts, really. Well, I wouldn't say it starts there, but it definitely perpetuates. That's the problem.
Yeah, that's like a negative effect that would occur, right?
Yeah, and it's also like, but that is like really hard to get out unless you're a bit more conscious about it and a little bit more free in experiments that you can do. And the ability to do more experiments is usually given by not having an end-to-end system, but by having all of these separate parts that you can just sort of swap out and play with.
Absolutely. And I would say also, like definitely during system design, very important to consider these things, and then also consider how you will, once your system is good to go, how you evaluate it. So specifically for recruitment stuff, are you familiar with Textio, Vincent?
It sounds like an IO website, so it's probably something techie.
It is techie, you got it. So this is they have several products, but it's an NLP startup, and one of the products that they offer is you use their analysis tool on job recruitment ads, and they have historical data about what type of ads have projected specific candidates, and they will help you identify language that might be perhaps subtly encouraging some group not to apply.
Okay.
At least a while ago, some of the terms that they were like, hey, maybe don't use these, are like rockstar or ninja or like warrior.
I've seen some linters on the internet for this sort of thing as well. Mm-hmm. Like on my old LinkedIn page, I used to boo recruiters a bit more. So every time I see a recruiter with like something I would consider nonsense, I just put it through the linter and send it back to them. So like stuff like bro talk, that sort of thing that attracts a certain crowd, but it excludes another types of crowd.
I saw one lately, and I was just like, oh, this is not for me. This person is looking for people who are not like Rachael.
this is some of the so these are some of those things where it becomes more obvious if you're hosting meetups and stuff. So for example, even if you're a company, you want to say, hey, we've got a nice social vibe going, we have this little bar and people can hang out and that's completely cool. And that is completely cool unless you're an introvert. Right? And then like, oh, I'm forced to drink beer with my colleagues. I don't even like beer. You're gonna...
Or if you don't drink alcohol.
Yeah, no, exactly.
Like if all your events are around alcohol, probably your Muslim colleagues are not going to be super into that.
Or just people who are pregnant. Right?
Absolutely.
There's a bunch of good reasons not to drink every evening. No, so like, and that's also something that's I've always found that to be fun. Like, Our Ladies is pretty big here in the Amsterdam ecosystem.
Our Ladies is great.
Our Ladies is like really pretty cool, especially because they just have a different standard. Like, you go to an Our Ladies meetup, and there might be like 2 people having 1 beer, and the rest is just a Coke or a tea or a coffee, and it's fine. It's all a bit more modest, and you can definitely notice that. I would argue it also attracts introverts, which I find like take my hat off for. Like that's hard.
Also, quick question from the chat from Yulong. Amateur question. Oh, we love amateur questions.
That's fine.
If we can detect the highly biased words, can we remove their biases by balancing parts of the data set? This is a great question. We talked about it a little bit last week. So just as a general approach, having some language data and then trying to do language data augmentation. Let me rewind. So data augmentation is super, super common in computer vision. So you have a bunch of photographs and then you include the same photographs, but like flipped or with like a little bit of a distortion or with a different filter on it. And it's extremely effective in improving how well computer vision models work. Data augmentation for linguistic data is much trickier. So the most common way to do that is through either natural language generation or doing back and forth machine translation is another thing that people do pretty commonly. So you'll start in English, you'll go to, let's say, probably not Dutch. Dutch is too close. Maybe like Japanese and then back to English, and like the wording will be slightly different. So that's one way. And then paraphrasing is another way of doing it. So you take sort of like statements and then you create surface level difference, but semantically very similar in meaning statements. The problem is, in general, the more artificial text is in your training data, the weirder your system gets and the less effective it gets. So the reason that we don't train chatbots by having 2 chatbots that talk back and forth to each other is that degrades extremely quickly into just nonsense. Yeah. Sorry, it looked like you were trying to get in there, Vincent. Go ahead.
No, but sometimes it also helps to make an analogy with something that's not NLP related. So this idea of resampling also pops up when you're doing, like, say, fraud analysis, where something that's like a class imbalance in a way. But also there, it's like really tricky. Like, you can undersample the class that you have a lot of. You can oversample the class that you have. You can add a little bit of random noise to come up with. But then you're changing the data as well. So you might also be changing the truth. And how much do you really trust your labels? Very similar problems, I would say. And in NLP, you kind of have this, you might have this unsupervised approach to language that might be able to help you out. But typically, you still need something of a human in the loop to just give it a little bit of direction to say, no, that's wrong. Some of these paraphrasing models, I was actually talking to a research colleague of mine today about this. So you can imagine that if you're researching paraphrasing models for digital assistants, then you would like all of your replies to be in the present sense, not in the past sense. And you would assume that a human also talks that way to a digital assistant. But if you think about Wikipedia and like all those prose, news websites, etc., those are often in the past tense. So there might be a bias to generating stuff in the past tense, even though that's completely invalid for whatever your goal is, right? So it's tricky.
Yeah, I think domain effects is, back to the paper, a great thing to bring up. Because the way that you use language in different situations is so sensitive, not only to what you're talking about, not the content, but also the social sort of milieu in which you're doing it. So if you go back and you watch a lot of the videos and you watch the reading club videos that I've done with Vincent and you watch the coding videos that I've done by myself, I would almost guarantee you that I sound more Southern when I'm just talking to myself, and I sound much less Southern and much more sort of like I'm using mainstream US English when I'm talking to Vincent. And that's
my English
just
is also
an effect of who I'm talking to.
no, that's just different depending on what region of Holland I'm in.
Absolutely.
If I'm talking to a Brit or someone from Ireland, my English also changes, and it's that's not just topic matter. That's also a way of saying things. I think that's human. In the same way that, hey, I'm taking something from Wikipedia, which is really formal, and I would like to use that to generate training data for a chatbot, which is usually really informal. It's tricky.
Yeah, and especially when you're trying to create a system that's mimicking social interaction, there's
I guess that's the way to also look at it.
I'm trying to come up with a good example of like paraphrasing where the denotation, the semantic meaning is the same, but the connotation is very different. So
I think when I was exploring GPT-3, I might have found one. So for example, let's say that you have a digital assistant, you want to rent a movie. Then if I were to do that now, I would not want to have a DVD.
True.
You don't. You're not interested in a DVD. However,
I want to stream. I don't want to wait for the mail.
Yeah. No, I mean, there's nothing like, okay, I do have like the boxed set of The Office, and and I'll keep that because if there's no Wi-Fi for whatever reason, I can always watch that. But having said that, this is one of those moments where, yeah, it's like GPT-3 is not inherently doing the bad thing, but it's just from a different era, so stuff is no longer valid. Even though the data is like maybe 10 years old, you don't want to have a DVD.
Yeah, no, definitely. So the social situation changes, and the world changes.
Yeah. New words are introduced.
Fresh.
Yeah. I'm kind of curious.
Which is why conversational-driven development is such a good way of approaching this type of system.
Oh. One thing I will say, one
sec. We're waiting to reconnect again.
Okay.
And I should say, usually when we reconnect, there's we don't lose a lot of data, but we'll see.
All right, it's like a couple of seconds or something.
Hopefully, depending on how quickly it does.
All right. It's interesting that we still in contact then.
Yeah, I think it's because the Zoom is way lower quality than when I'm streaming. So I think it's probably just a bottleneck issue.
Could be.
And Mady says, okay, we're back up.
Yay.
TARS Android hyperparameters again. I don't know what that means.
Is there a sentence above this, or?
No, I don't think so. I'm just gonna Google that. How does one unpack a tar file on Android? It's a U.S. Marine Corps tactical robot. Oh, from Interstellar. Okay. Oh, I think this is a movie reference. Okay, I think I'm picking up what you're putting down now. And you could change his personality. Okay, yeah, I vaguely remember this. I did watch that movie. I found it kind of upsetting.
I've not watched the movie, but
it was good. It was very intense.
All right. Usually at the end of the day when I'm tired, I'm also not really into intense movies. I'm a little bit.
Same.
Yeah. One. I've got a curious question. Are there still other questions? Because I might have a fun one to end this with.
I think we've hit everybody from the chat who asked something. I thank y'all for being A, patient with my internet issues, and B, engaging with the material.
Good questions this time around.
What was your question, Vincent?
Well, so obviously we see downsides, right? We shouldn't, this is danger zone, so you got to be mindful. You got to be careful. You got to measure and do all that. What are some applications where this might be less of a concern? So I'm kind of reminded of this image detection task I did for a client before, and we kind of came to the conclusion that, detecting things in photos is fine. Detecting people is scary. So just as a team, we kind of said, we're just not going to do any detection of people or anything. Like, we're just going to not do any of that.
To clarify, not there is a person in this photo, but this is John Smith, 1234 Main Street.
Neither. So and also this was like for more of an industrial client. So the main thing they were interested in, like, we have to detect a certain object, and that's the main, like, for automated checking purposes, that's the main thing that they were interested in. But also kind of as a team, we just said, we just want to avoid this whole privacy situation thing and like all these things that might go wrong. So image detection on things is okay. That's an okay sort of convolutional neural network stuff. That's fine. Like, if we just detect things, let's not detect people. And I'm kind of wondering if there's a similar thing for word embeddings here. Like, you might, there might be some use cases where you can say, well, like for Rasa, I can argue that because we have these natural constraints built in, there's these intents and like mainly we're building systems for frequently asked questions and stuff, right? But what are some other applications where you can kind of say, well, if you're in that region, it's less of an issue?
Yeah.
I mean, it's easy to point out that recruitment is definitely danger zone, right? So
absolutely.
The question is there also something on the other side of the spectrum?
Two things. So first, just to go back to your example of detecting people, where I come down on that is I think it's okay to detect that there is a person, particularly for industrial applications. For example, to do safety monitoring and like no one should be in this room. If somebody's in this room, you can't turn on the machine. I think having like that sort of CV as a kill switch. That's
like a safety mechanism you can do there.
Yeah, exactly. Although I definitely agree, recognizing this is John Smith, 1234 Main Street is, I would not recommend that almost ever.
That's a no-no, yeah.
Yeah, pretty big privacy concerns there. In terms of text applications, so I mentioned for abusive language, having this information in the embeddings might be specifically helpful because a lot of abuse does tend to be very gendered, and be able to notice, hey, these are really extreme terms, we might want to keep an eye on these. Could be useful. I think in general the places where I would be most hesitant to use it would be, I gotta bring up the slide again. Places where people can't opt out of using the system. It's making important decisions for them. They can't appeal those decisions, or they don't have a way to easily appeal those decisions, where it might, increase systemic bias. So jobs and application to employment, obviously a place where systemic bias has been a thing in the past, and continues to be in the present, and you could very easily, if you're using historical patterns, reinforce existing biases. But I think like playful monitored applications, I don't think it's necessarily bad to have these sort of biases. So for like games, perhaps, if there is a system in place to
but that's more generative though, right?
It doesn't necessarily have to be.
That's true. Yeah, okay, you're right. The generative is a use case for gaming, but you can also do some stuff here.
I think you're working on a game that's not generative right now. Spoilers.
It's not announced yet.
Redacted.
Yes. It's going to be super fun, but it's not announced yet.
Yeah, no, I'm really looking forward to it. Keep your eyes peeled.
Yes. No, so like I've actually been thinking about this for a while, because it's easy to point the finger, right? And it would also be nice if you can point the finger in the right direction. And I can definitely imagine like, hey, we've got this ticketing system, and let's say that you have a problem with the API, and you're a Python person. Okay, then you go to the Python specialist. Like, maybe some automation there, right? But that's also because you're applying text not on people, you're applying it on a thing more. So from it, I'm wondering if like that I like that feeling, right? If I'm not influencing people, that's already a bit better. Then you've got the recommendation field, and there already it gets kind of tricky, because then you're influencing people. Yeah. It's already kind of tricky.
Yeah. don't necessarily know that gender bias is always a problem in recommendations, you know?
Okay, well, I can give one. Unfortunately, I know a couple of the examples there. So,
Yeah, no, please.
so suppose that you're.
Talk about it.
So let's say that you misspell the word barbecue.
Mm-hmm.
Okay, then I, the seller, know that you're the kind of person who would misspell barbecue.
Dyslexic?
Well, for example, right? But I already know a couple of things there. Like the way that you spell a word, right?
Mm-hmm.
I can kind of analyze that to sort of squeeze every dollar out of you.
Mm.
And then the question is, well, to what extent is that ethical, right? There's a gray area there. I don't want to suggest that all recommenders are evil. That's also wrong.
So this is specifically for ad tech.
Yeah, and then ad tech is of course also, yeah. So ad tech, I guess you could say Amazon is also. I wouldn't say Amazon is ad tech, but you get a similar phenomenon there. You got some sort of marketplace.
Like an example that I think is sort of more neutral is I tend to prefer female vocalists in music. So a good music recommender system for me will notice that pattern and recommend more female vocalists than male vocalists to me.
Oh, but then maybe what we're looking for then is maybe a recommender is a bit unfortunate because the person doing the recommendation might not have the interests that you have, but the ability to customize will be great. And I can definitely imagine that this technology can contribute to that. Well, okay, so then in that sense, you can definitely still have some good areas of recommendation that are cool, but then you could do some customization, I suppose, there.
But it's good to, I think, it's good to know about, it's good to consider, and then for your specific application, the thing that you are particularly working on, really think about like the worst case scenario and the best case scenario. So like, for music recommendation systems, if I stream somebody's music, they get paid. So if I'm only recommending male artists, women are not going to get paid, or vice versa. So thinking about the worst case scenario and working to actively mitigate that during the design and building and maintenance of your system, I think is very important.
Yeah. And then we haven't even touched on the bird stuff, to be honest. These are just the simple word.
Yeah.
I
don't think. Yeah. Is there? I haven't seen a similar paper for BERT. Have you? Or any of the language model stuff?
I haven't looked, but it's mainly because I've been preoccupied with just the vocabulary-based stuff, if I'm honest.
Yeah.
Like the thing is, like I think this paper does a good job of disappointing me on how well we are at debiasing, and I don't think that BERT's going to be improving. The only thing I suppose, actually, I might have one saving grace actually here. So I know a person who gave a talk a while ago. She's from the Netherlands, and she explained that one thing that BERT is actually quite good at. She had this example of those corporate quarterly reports, like this is how well we're doing, these are our challenges, etc.
Yeah.
She was trying to figure out which companies were doing well on sustainability. There's a couple of companies who have to report on sustainability. Now, if you're writing such so if you're writing such a report and you're actually not doing that well there, you're not going to say we suck. You're not going to say that. You're going to say something along the lines of, well, we think we have really engaging challenges ahead of us in that theme. And that's like one of those language subtleties. The order of the word here matters. And this is one of those regions where BERT can actually kind of make a difference because it's not just the word embeddings, it's the order in which they appear and how they influence each other.
Yeah.
That's where a transformer makes sense, which is great. And I can actually imagine that for curse words, like we previously mentioned the example where you say, well, I'm gay, then in that sense, it's not used as bigotry, right? Something like BERT might
I mean, depending on the situation.
Sure, of course, but the thing is, but there's context involved there, right? And that's the thing that BERT might actually alleviate in that sense. So I don't want to suggest that this is a given, but I do want to suggest that there is an option there.
Yeah, it'll probably be different, right? Hopefully better. Yeah,
so what I can imagine at least subtlety being. Well, the thing is, you can still overfit on subtlety. That's also an issue. But you remove some of the issues that word embeddings have. So there's something about that. I think it's nice to at least mention.
Active area.
Yeah, active area. I don't know how debiasing might work there. I'm skeptic.
Yeah, I think it's very much an open question.
Yeah. I also think that when was this paper written? Actually,
I want to say like 2016, 17. I think it came out while I was, let's see. Oh, 2019. I was way off.
Yeah, so the thing, if I think about the hype cycle, I remember like 2016, 17, like 2017 and 18, I remember, hey, that's when the RNN started doing well on these deep learning tasks and the word embeddings became like production ready. Someone wrote
all bidirectional LSTMs with attention.
Yeah, and also like someone wrote that the ImageNet for NLP has arrived. That moment, someone wrote that.
That might have been about the transformer paper, which would have been 2017.
Yeah, could be. Like I think 2017. I think the paper was already there, but it wasn't used in practice that much.
Yeah.
There's always this lag.
Traction.
Yeah. So one thing I think about this paper, it is relatively late to the game as far as word embeddings go. So I think also, I don't know, like it's hard for me to estimate how much influence this paper had. I've heard many people know it though, so I think the paper made an impact. So
and I would say, I know that embeddings are not like vector embeddings aren't like the hot research topic anymore, but people definitely use them.
Yes, that's the thing. And I think that's the thing. So it's not being researched maybe as much. I think bias is still active, like that field.
Yeah.
But then a couple of years later, you do have all of these packages that you can just pip install and then use. And I think that's more the phase where we're at. So I think there's definitely still a lot of bias research happening. I also think the bias research is something that took off somewhat recently. I don't know if you can confirm that, but the feeling I have.
Yeah. So it definitely...
It feels recent in that sense.
So people have been working on it for a really long time, but a lot of them were sort of not in core NLP. There are a lot of people working on like socio-technical systems and lots of ethicists and philosophers. And then the NLP conversation around bias, fairness, accountability, and transparency, I really want to say started kicking off, 2015. I think a lot of conferences started happening.
I would argue that's kind of where the start was, yeah. Like scikit-learn definitely was around for a while, but people started talking about it in 2015, and at least when I look at PyDatas, it feels like the last 2 years.
It's definitely gotten more urgent.
Yeah, so there's a sense, there's a sense of urgency, but also it's becoming a bit mainstream as well.
Which is great.
Yeah,
I think it's something we should all think about all the time.
Yeah, it's certainly not a bad thing. This sort of thing's happening more, but so it'll be interesting in that sense. I don't know what's going to happen with bias and that. Like I think from a philosophical level, I will be really surprised if you can come up with like a proper debiasing method that everyone can agree on. I think you're never really going to get there because
I would agree. People's
opinion on bias is different, and it's a super hard technical problem. Even if you could get everyone to agree with just this paper.
My sort of stance on the matter is debiasing is good. I think it's
noble,
a helpful toolkit to have.
Yeah, I agree.
But you're going to do the most good and have the most effect in terms of building fair, useful systems, like well before the point where debiasing is the thing that you're thinking about,
Yeah, it's like, I think it's a methodology thing as well. So suppose that you've got the perfect grid search, your methodology A+. But your feedback.
Although in general, I would not recommend grid search.
No, but let's say the grid search is part of your pipeline, and you do your methodology proper there. Like, I'm not suggesting grid search is the best thing ever, but it is a good thing if you do grid searches. You have some sort of methodology involved there. So let's say you do the good thing. You pick the right model according to grid search. If your feedback mechanism is messed up, you're still solving the wrong problem, right?
Yeah, definitely. Or if you have built a model that there is a clear harmful application for, no matter what reason you built it for, that's not something you're going to fix with debiasing.
Yeah, true.
That's the pig. You shouldn't keep giving the pig a makeover. You should be like, okay, we're not going to release this pig into the wild where it's going to destroy the ecosystem.
And also, I think that's also one of the points of the paper. I mean, even if we have if we talk about fairness and that sort of thing, there are so many metrics for it, right?
Mm-hmm.
And they also disagree with each other very, sometimes. So even if someone says, well, according to my metric, this is a rhino, not a pig, still someone else can come in and say, well, it's for your use case maybe, but to me. But yeah, this is a nice paper that makes you sort of rethink some stuff. So that's always good.
Yeah, definitely. And I think also provides nice context as the word I'm looking for the larger debiasing literature.
Yeah. And I suppose the final comment, and it's making me appreciate one more time, and this is relevant because I've been thinking about adding that to my library. Good curated word lists. I think that is something that I think deserves something that you can pip install, because you need them in different languages as well, and it's actually something that might benefit the research community a fair bit if we just can kind of agree on what a good word list is, because even stop words are things that even stop word lists apparently have lots of issues with them. I recently found.
Oh, very much so, especially for low resource languages.
Yeah.
One thing about word lists for very low resource languages is that often they are just machine translated from English, which is not necessarily going to match the frequency distribution of the other language. And so if you're looking for, or you're reading through word lists for a lot of these low frequency languages, a lot of the words are just English words that have not been translated.
Are you serious? Oh, that's really bad.
Serious.
Oh.
Yeah.
Huh. I have heard, that was actually a thing I did find interesting. So I was talking to someone from, I forget the country in Africa, sorry, but the main point was that he had a language where he basically said, well, our Wikipedia pages are just not up to snuff. It's not really, it's not at all how people use language on their phones. So that was a reason for that person to say, well, I would love to be able to train my own word embeddings.
Yeah.
For Rasa specifically. By the way, as of today, you can now use GenSim with Rasa. Go to the Rasa NLU examples project, and you can totally train your own embeddings. But low resource languages have problems that I did not anticipate in any way or form. You would assume that in most languages, Wikipedia is up to snuff, but it's just not the case.
Nah.
It's really.
I mean, there's 7,000 languages.
Yeah,
there's a couple hundred on Wikipedia.
I was really proud when I had this embedding for 270 languages for Rasa. I was like, oh, it's going to help so many people. And they discovered that there's thousands of languages, not hundreds.
Wow.
Which is kind of a bummer, but this is again, good paper. It's been fun reading this.
Yeah, definitely. I've had fun.
Good paper.
Hello near this. Sorry, I keep reading that as hell on earth, which it definitely isn't. It says, how people use tools can always use them in bad ways. That's true. And I think as developers, it is our job to make sure we're using our tools well. Well, speech error there.
And that's actually maybe a cute point there, I suppose. And it also has to do with Rasa, I guess. Especially if you're a developer, you should recognize at any point in time that the whole awesome thing about being a developer and having Python at your disposal to do machine learning, as opposed to, say, SPSS or a software package, is that you can customize. So if there's a part that you don't like, odds are you can actually fix it. If there's not a button somewhere that does the exact thing that you want, you can change it. And that's a power that you should use. And that's also what I like about Rasa. If there's any part of Rasa that you don't like for whatever particular reason because it doesn't apply to your specific use case, go ahead and change it.
Oh. I think it's a good note to wrap up on. Now it's getting a little bit late for you. Thank you, everybody, for joining us today. This has been the second half of Lipstick on a Pig. Debiasing methods cover up systematic gender biases in word embeddings, but do not remove them. And I think the TLDR is check
careful.
Your word embeddings. Yeah, be careful.
Be careful and be skeptical. Debiasing is a very cool idea. People should definitely keep researching it. But you should not assume that it's a button that you can press and that removes all the problems.
Yeah. I think be careful and be skeptical is a good sort of summary of my ethos in general. Next week, so tomorrow we'll be having the live coding. Y'all are welcome to join. Hopefully this time I can get my gosh darn cluster working right. And then next Thursday, we will be starting with a new paper. And I've got some ideas, and I think what I'm going to do is put them up to a vote. and see what people are into. So probably do that on YouTube and maybe on the Twitter and maybe on, if you're a contributor, the contributor Slack. And we'll figure out what will be most interesting to folks.
And you can always reach out to either myself or to Rachael if you think that there's an awesome paper that we should definitely
Absolutely.
do. Odds are we are not aware of every single paper out there.
Oh, I know I'm not.
Yeah.
All right. Thanks so much for joining me today, Vincent. Thank you so much for joining everybody in the chat.
That's been fun.
We will see you